Hey everybody, today we're solving absolute value equations. If you know what those graphs look like, we got that little V shape. And then when they're equal to some other equation or some other number, what can happen is that can go ahead and be a line that intersects twice. It could be an absolute value where it maybe only intersects once because it hits the vertex. Also, sometimes there's like parallel lines that could happen like that where it only intersects once. And sometimes there's an absolute value shape or an absolute value graph that the line goes underneath and we end up with no solution. So what happens, especially on some of these weird ones in the middle, is called an extraneous solution. And the way that you can solve an extraneous solution or check if there's an extraneous solution is simply by plugging your answer in at the end, which you're supposed to do in math anyways, but today we're taking it to that next level, to Algebra 2. We definitely are going to check our answers to see if this new topic of extraneous solution comes up. But otherwise, we're just undoing like we've done with all of our other equations in class so far. So that brings down our absolute value equal to a negative 12. We go ahead and undo that 3 out front. I like calling that extra junk. You can do the problem and distribute the 3. I like to undo it, make the numbers smaller, make the numbers easier. We get down to just the absolute value. That's the goal. Get down to just the absolute value. Then we can go ahead and break those into our two equations. We've got x minus 1. That always stays the same in both of our equations. On one side, we have a negative 4. On the other side, that's going to flip to a positive 4. Cool, we go ahead and solve the rest of the problem. We add 1, we add 1, we add 1, we add 1, undo, bring down our solutions. X equals a negative 3, x equals a 5, and remember that sometimes absolute values give us very weird possibilities. Sometimes it gives us no solutions. In this extra solution, we're going to go ahead back to the original and plug it in and see what happens. Well, I'm going to go ahead and plug in the positive 5. That's a little bit easier. So when I plug in a 5 into the original, 5 minus 1 is 4. The absolute value of that's still 4. 3 times 4 is 12. 12 plus 2 is 14. 14 does not equal negative 10. That is an extraneous solution, an extra solution. Even though I did some math, it did not work out. When I plug in the negative 3, negative 3 minus 1 is negative 4. Absolute value turns into a positive 4. 3 times 4 is 12. 12 plus 2 is 14. Does 14 equal negative 10? Nope. There is no solution to this problem. We actually could have learned that a little bit easier right here at this moment. Absolute value will never be equal to a negative number. So if you get down to your absolute value bars and it's equal to a negative number, at this moment right here, I can write no solution and save myself some steps of plugging those in just so I don't have to do all that extra work. Cool. On the next one, we undo. We go ahead and subtract. We get rid of that, and we are down to something we've never seen yet in class, which is an absolute value equal to a 0. Once we're down to the absolute value, we separate into our two equations, just like the absolute value graph. We got x plus 7 in both of them. Don't change the equation. The only thing we're allowed to change is the answer. On one side, we have a 0. On the other side, we have a negative 0? That's weird. Oh well, just keep doing our math and undo. We subtract 7, undo it, x equals negative 7. Negative 0 is just 0. There's no value, so it doesn't matter if it's positive or negative. When I subtract 7 from 0, I still get negative 7. So really, I only have one solution. This is like that V-shaped graph, just coming down and touching at the vertex only once. Let's go ahead and plug it in and make sure that it works. It's not an extraneous solution. Plug in negative 7 back to the original. Negative 7 plus 7, 0. The absolute value of 0, 0. 0 plus 4 is 4. Boom, that works. So really, we only have one answer. I'm cool if you write it twice. No worries, I'm not going to take off points or anything like that. Cool. I'm going to go ahead and move those out of the way, and we'll take a look at our next two problems. Number 3, we have an absolute value, and there's no extra junk, as I like to call it. So we're ready to go ahead and break it into our two equations right here at this moment. We have x plus 3 equals and x plus 3 equals. Notice I'm not changing the original equation. On the right side, we're going to keep it the same as it was for one of them, and we're going to flip it on the other, negative x, and then a negative 5. Then we're going to go ahead and solve some undoing. Let's go ahead and get rid of x, I'm going to go ahead and add an x here and add an x here. Cool, x minus x eliminated, gone. 3 equals. X minus x eliminated. Does 3 equal 5? No, never. That is a no solution. But I don't want to write no solution because there might be a solution over on the right side. But that one's definitely not an answer over there. Cool, I'm going to go ahead and bring down my work over here, which is 2x plus 3 equals negative 5. Welcome back to middle school math. Go ahead and subtract those 3's on both sides. 2x is equal to negative 8. Divide by 2, x equals negative 4. Let's go ahead and double check and plug it in and make sure that it works and it's not an extraneous solution. Let's plug it into the left side. Negative 4 plus 3 is negative 1. The absolute value turns it to a 1. Let's plug it into the other side. Negative 4 plus 5, 1. Cool, we have one answer, so that's why we definitely don't want to write no solution over there. There is a solution. Cool. Number 4. On 3 and 4 here, what we're seeing is an absolute value V shape that's equal to x's, so it's a slanted line, a slope of 1 or a slope of 2. That V shape could slope underneath and not hit it. It could slope up top and hit twice. It could slope and hit the vertex just once. So we got to do that math and see what happens. On number 4, there's some extra junk. Let's go ahead and divide by 2. Got to make sure I divide by 2 on both sides there. I undo that, and I get down to just the absolute value. Sweet. 2x over 2, that's an x. 6 over 2, that is a 3. Now I'm down to the absolute value. I can go ahead and break that off into my two equations. The x plus 1 never changes. The x plus 1 never changes. It's only the answer side that changes. So one of them is going to be an x plus 3. The other is going to be a negative x and a negative 3. I see something that might be happening here when I subtract x's on both sides. They are gone. Does 1 equal 3? Nope. I can't write no solution though because there might be a solution on the other side. Let's go ahead and check. Let's add x. Let's add x. That gives us 2x plus 1 equal to negative 3. Welcome back to middle school math. Go ahead and subtract a 1 on both sides. That's gone. We're undoing. 2x is equal to negative 4. Divided by 2, and x equals negative 2. Let's make sure it works and it's not an extraneous solution. We go back to the original. I might have to erase a little bit to see that original there. So if I plug in negative 2, negative 2 plus 1 is negative 1. The absolute value turns it to a positive 1 times 2. We got 2 on the one side. Let's see what happens on the other. 2 times negative 2 is negative 4. Negative 4 plus 6. That's a 2. Those are equal. Check. That one works. So I can't write no solution earlier. There is a solution. It is that right over there. Sweet. I'm going to drag on down to the last problem. And we've got some extra junk, as I like to call it here. We can't solve for the absolute value just yet. Go ahead and add that 4 out of the way. Add that 4. Get that out of the way. Let's go ahead and focus on that absolute value right now. We've got negative x and a positive 8. We got our absolute values. We can go ahead and undo those, break them down into the two equations. The 3x stays the same on both sides. Negative x plus 8 stays the same in one of them, and that negative x is going to flip to a positive on the other side, and the positive 8 is going to flip to a negative on the other one. Cool, we're going to go ahead and do some middle school math. That gives me 4x. That gives me 8. Divide by 4. We get x equals 2. Does it work? I don't know. We got to plug it back in. I'm going to go ahead and check that in a second. I'm going to go ahead and do all my math here first. Do all my algebra. And negative 8. Do some division. And I get x equals negative 4. Does it work? I don't know. I got to plug it back in. I probably need my eraser to erase and go back to that original and double check. All right. Let's go ahead and plug in 2. So 3 times 2 is a 6. 6 minus 4 is giving us a 2. And if I plug in a 2 right here, that gives me negative 2 plus 4, which is a 2. Sweet. 2 works. That's kind of weird that the 2 led us to 2. That doesn't have to happen. But does 2 equal 2? Yes, it does. Cool, now we're going to go ahead and plug in the other one and see if the other one works. Negative 4. 3 times negative 4 is negative 12. The absolute value turns it positive. 12 minus 4 is 8 on this side. And on the other side, a negative 4 plugged in, a negative 4 plugged in with a negative is actually turned to a positive 4. A positive 4 plus 4 is also 8. Those equal, so that is a solution. Both of those work for the last one. There's absolute value. Check your answers to make sure there's no extraneous solutions. Peace.